Hello, dear students. Let us discuss about your board question answer regarding maths with some geometry portion. Okay, so we are discussing various questions in our regular videos. Today also we will discuss some different type of questions, new type of questions. Okay, so first understand the question. The two triangles are there, ABC and DEF. Okay. Having the data is given, triangle ABC similar to triangle DEF. Okay. And in triangle ABC, AB is given 8, 6 cm, D is given 9 cm, and DF is given 12, and EF is given 6. So we have to find out the perimeter of ABC. Perimeter of ABC. How to find out perimeter of ABC? Okay. So we know that if two triangles are similar, their corresponding sides are in the same ratio. Okay. So if ABC triangle and DF triangle are similar, I can write AB by DE equal to BC by EF equal to AC by DF. Okay. But AB by DE we know 6 by 9. So what ratio it is in? It is 3 2 3 3. It is in ratio 2:3. It is in ratio 2:3. So every side has a common ratio 2:3. DF and AC are in the ratio 2:3. It means if it is 12, what will be the AC? To find out the perimeter of ABC, we have to find out all the three sides. So we have to calculate the side of AC and BC. So we know the corresponding sides are in the ratio 2:3. Okay. So what will be the length of AC so that AC and DF will be in the ratio 2:3. Okay. So what will be the AC by DF equal to 2:3, and AC is we have to find out, and DF is 12 equal to 2:3. Okay, so AC will be how much? AC will be 2:3 is to 12 into 12. This will be multiplied in the other side. 3 4 8. Okay. Similarly, 2:3 of 6 will be the BC, because AC is 2:3 of 12. Similarly, BC and EF is also in the ratio 2:3. Similarity theorem. So 3 2 6. This will be 4. Okay. So all sides are in the ratio 2:3. This is given 2:3. This is 2:3. 4 2 4 3. This is 2:3. 2 2 2 3. Okay. Now we can calculate the perimeter. 6 plus 4 plus 8, 18. So the perimeter is 18 cm. Okay. So let us proceed to question number 2. Could you follow this one? Okay. So these types of number is common in your board. Okay. So if you are having problem in your assertion and reason, we will discuss in our next video that type of questions. Okay. So let us discuss different type of questions. Another number is, see the question, in a triangle, in a circle, from the exterior points T, two tangents are there, TP and TQ. This is the center O. Let me change the pen. TP and TQ. Okay. And PTQ. 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 Here PQ is there. PQ is PTQ. PTQ. You have to prove PTQ equal to 2 into OPQ. OPQ. It means if this angle will be double of this angle. How to prove? Okay. Let's see. Let's start with proof. Okay. We know that from an external point, the length of the tangents towards a circle is same. So TP will be equal to TQ. It means that these two angles will be same. TP equal to TQ. It means that I can write TQP equal to TPQ. Okay. This is a tangent TP, and this OPQ along with TPQ, it makes a right angle here. Theorem 10.1. That's the tangent passing through the radius makes an angle 90 degree or perpendicular to it at contact point. This is 10.1. So TPO, angle TPO, see TPO is 90 degree. Okay. Similarly, TQP also 90 degree. TPQ, this one, the same thing, 10.1. TQP also 90 degree. Okay. TPQ also 90 degree. Let's start. How to prove? Okay. You know that in triangle TPQ, the sum of three angles are 180 degree. So TPQ plus PTQ plus PQT is 180 degree. Okay. So I am writing this one towards left because I have to prove this one in the left side. So PTQ, I am writing PTQ, this one first, plus TPQ and PQT are same. TP equal to TQ and TQP is TPQ. You know that if these two sides are same, their front angle will be same. Okay. So I can write TPQ and TQP will be same. So I can write 2 into TPQ equal to 180 degree. These two are same. So I can write 2 of this or 2 of this here because these two are same. These two angles are same. So I can write for this angle, I can write this angle. So this plus this, 2 into this. So I have written in this manner. Why I am writing this? Because I will get OPQ here from this 90 degree angle. That's why I am taking this angle in place of this angle. Okay. So PTQ, I have to place it in LHS, plus 2 into, what is TPQ? TPQ when adds with OPQ, it makes a 90 degree. So we have to bring OPQ also in our equation. That's why I am adding this one. Okay. So 2 into OPT minus OPQ. I am bringing this angle to make the proof proceeding. So I am writing TPQ, this angle, TPQ as OPT minus OPQ. Because I will get 90 degree here, OPT is 90 degree, OPT is 90 degree. Okay? OPT is 90 degree. So that's why I am writing this 90 degree minus this OPQ is this angle. For this angle, I am writing the right angle minus this angle is this angle. I am writing just this. 2 is there, so I am 2 is multiplying in this line also. Okay. So next, right? See, PTQ plus 2 into OPT minus 2 into OPQ equal to 180. Okay. See. Okay. Now just 2 into OPT. OPT is how much? 90 degree. I have told you. So PTQ plus 2 into 90 degree equal to 180 minus 180 plus 2 OPQ. I have taken this minus 2 OPQ this side, so it becomes plus 2 OPQ. Okay. Now PTQ plus 180 degree equal to 180 degree plus 2 OPQ. See, I am explaining this line. PTQ plus 2 into 90 degree, we know that this one is 90 degree, OPT 10.1, 2 into 90 degree, 180 degree. 180 is already in the RHS I have written, and this line I have already copied this one. So, cancelling both sides, 180, 180, having same sign, or if you take this 180 to other side, it will be minus 180, and this will be cancelled also here. So you can cancel in this step also. That's why PTQ is equal to 2 OPQ. Proved. Okay, finished. Okay. Understood? We'll discuss about different type of problems in our next video. Thank you.